Welcome to The Explainer. You know, we hear the term breast cancer all the time, but what does it really mean? Well, today we're going to pull back the curtain and show you why it's not just one single thing. It's actually a whole collection of different diseases, and each one plays by its own set of rules.
So let's kick things off with a huge number. What if I told you that somewhere between 80 and 85% of all invasive breast cancers are actually the same type? Yeah, the vast majority fall under just one name.
And that name is invasive ductal carcinoma, or IDC for short. It is by far the main culprit, and as you can see from the subtitle, its whole story is about breaking out of its original home, the milk duct. Okay, so let's break this down. The most important word on this slide is invasive. That's the whole ballgame. It means the cancer cells aren't staying put anymore. They've punched through the duct wall and are now in the surrounding breast tissue. And once they're out, they can spread. Usually this shows up as a hard, painless lump you can feel. And interestingly, the most common version is so, common that its official name is not otherwise specified. It's kind of like the default setting for breast cancer.
Right, so that's the big one. But now let's meet its counterpart, the second most common type, which is invasive lobular carcinoma, or ILC. And trust me, this one is a completely different animal. It's much, much stealthier.
So what makes ILC so sneaky? Well, it's all about how it grows. You see, the cancer cells lose this protein that acts like cellular glue, the stuff that normally holds them all together in a clump. Without that glue, the cells break off and march through the breast tissue one by one in these long single-file lines. And because they do that, they never form a solid lump, which makes them incredibly difficult to find.
And that leads to this perfect description. Doctors often describe the growth pattern as being like the web of a spider. It's not a rock, it's a network, silently weaving its way through the tissue. It's a really powerful image, and it captures exactly why this type is so different.
So how do you even find something like that? Well, doctors look for clues, and that leads to some really fascinating clinical buzzwords. On a mammogram, instead of a white lump, they might see the tissue being pulled inwards, creating a distortion. They call this a dark star, all the gravitational pull, but with no obvious mass at the center.
And here's another one that's a bit of a mind bender. The shrinking breast. Now, the breast isn't actually getting smaller, but that spiderweb of cancer cells makes the tissue really stiff and hard to compress during a mammogram. So on the image, it just looks smaller than the other side. It's an illusion created by the cancer.
And finally, on an ultrasound, you get this, a shadow. You can see something is blocking the sound waves, but when you look for what's casting the shadow, there's no obvious mass there. It's another clue that you're dealing with that sneaky, infiltrating pattern of ILC.
Okay, so let's put these two head-to-head. IDC, our main culprit, forms a lump. ILC, the stealthy one, makes that spiderweb. Because of how it spreads, ILC is also way more likely to show up in multiple spots in one breast, and even in both breasts. But this last point is a really big deal. When they spread, they take different paths. IDC often heads to the lymph nodes in the armpit, a predictable route. But ILC, it can pop up in really unusual places, like the lining of your stomach. They are truly different diseases.
All right, so we've met the two big stars, but the story doesn't stop there. Beyond IDC and ILC, there's a whole gallery of less common subtypes, and we're going to take a quick tour.
We're just going to hit the highlights here. You've got tubular cancer, which is slow growing and has a really good prognosis. Then there's mucinous, which also has a better outcome than the standard stuff. Medullary is pretty interesting. It also has a good outcome, but a quarter of the people who get it have the BRCA1 gene mutation. And finally, papillary, which tends to be found in older patients. See, each one has its own little personality.
Now for a special case. This one's called Paget's disease, and it's less of a type of invasive cancer and more of a major warning sign. It looks like a rash, kind of like eczema on the nipple that just won't heal. But here's the kicker. In a staggering 96% of cases, that little rash means there's a high-grade cancer hiding in the ducts right underneath it. It's a red flag you can't ignore.
Okay, we need to pivot now. We're shifting gears from the less common types to the most urgent, the most aggressive presentation of them all. This is inflammatory breast cancer, or IBC. And it is, without a doubt, a clinical emergency.
Yeah, the source material does not pull any punches here. A notoriously terrible prognosis. And a big reason why is its speed. It's so aggressive that for about a third of patients, by the time they are even diagnosed, the cancer has already spread to other parts of the body. One of the classic signs of IBC is something called peau d'orange. It's French for skin of an orange, and that's literally what it looks like. What's happening is that tiny clumps of cancer cells are clogging up the drainage channels in the skin. It's like a traffic jam, and it causes the skin to get thick, swollen, and dimpled, just like an orange peel.
And this brings us to what makes IBC so dangerous. It's the great mimic. It shows up as a red, swollen, hot breast, and it happens fast. And there's usually no lump. So what does that sound like? An infection, mastitis. And that's the trap. So there is a critical rule in breast medicine. If you treat what looks like an infection with antibiotics and it doesn't get better in a week or two, you have to assume it's IBC until you prove it's not with a biopsy. It's that serious.
Whew. Okay, we've gone from the most common to the most aggressive. Now let's hit rewind and go all the way back to the beginning. Let's talk about the prequel to this whole story, DCIS.
DCIS is what's known as stage 0 breast cancer. The abnormal cells are there. They're cancer cells, but they're completely contained inside the milk duct. The term in situ literally means in its original place. Think of it like a fish in a fishbowl. The fish is there, but it hasn't broken the glass yet. That duct wall is still holding everything in.
So, on its own, DCIS isn't life-threatening. The problem is, it's the precursor. It has the potential to break out and become one of those invasive cancers we've been talking about. And get this is a wild fact. When doctors do a small needle biopsy and diagnose DCIS, in up to a quarter of those cases, when they go in and surgically remove the whole area, they find a small hidden spot of invasive cancer that the needle missed.
So after all this, why does it matter? Why do we have to know all these different names? Because breast cancer is just the chapter title. IDC, ILC, IBC, Paget's, those are the actual stories. And knowing which story you're dealing with changes absolutely everything. The prognosis, the surgery, the treatment, it is the most important piece of the puzzle.
And that really leaves us with one final thought. We're getting so good at understanding these tiny differences between cancer types. The future isn't just about knowing if it's IDC or ILC, it's about understanding the unique genetic playbook of an individual person's cancer cells and designing a treatment to beat that specific playbook. And that is a very hopeful thought. Thanks for joining us.